And then one of the interviewers kind of turned to me and said, okay, you've got 30 seconds, tell me the mass of oxygen in this room. Hey guys, welcome back to the channel. My name is Arun. I'm a junior doctor working in London, and on the side, I try to put out some of these kind of study YouTube videos. So in this video, we'll be looking at one of those weird questions that got thrown to me at my medicine interview for Cambridge. Just for a little bit of context, I had 3 interviews for Cambridge. The first was a very general interview asking a little bit about my personal statement and why I wanted to study at Cambridge. The second was a very scientific interview, and then the third was a more human biology, medicine style of interview. Before we jump into this question, if you're watching this video and you have your interview coming up very soon, then if there's just 2 things that you take away, please let them be these 2 things. Number 1, please talk out aloud, please think out aloud during your interview. The interviewers, they're so much more interested in the way you're thinking, the process behind your thoughts, rather than you just getting to the correct answer straight away. And also, just by thinking out aloud, you're able to kind of gauge from the interviewer's response if you're on the right track, so please think out aloud. And number 2, if you think it will help and there's a pen and paper available to you, then please use it. If you think you can draw something with it, write something out with it. I think it helped me stay really calm and just kind of think straight during my interview. Okay, so onto this question. I think it was coming towards the end of my second interview, which was the very scientific interview. And then one of the interviewers kind of turned to me and said, okay, you've got 30 seconds, tell me the mass of oxygen in this room. And I think for the first few seconds I panicked, I didn't say anything at all, and then I knew I had to start with something, I had to start thinking out loud. So I took the pen and paper they gave to me and just started writing. Okay, so we know we want to end up with the mass of oxygen in the room. So just to kind of keep that in mind, I'll put it over here. We want to end up with mass, which is grams, or let's just say kilograms, one of those units. We have to start somewhere though, and one place we can start is with the volume of the room. So let's start with that volume of the room. And we'll just keep things really simple, just to keep the math simple. Let's just say this room is 2 meters by 2 meters by 2 meters, which gives us a volume of 8 meters cubed. Okay, so we've got the volume. We now need to think about what the next step might be. And kind of thinking back to our chemistry GCSE, we know there's that law which says that 1 mole of gas at room temperature and pressure has a volume of 24 decimeters cubed. So we can use that to work out the number of moles in 8 meters cubed. So that's what we want to do next. We want to convert this volume into moles. Before we do that, the first thing we need to convert meters cubed into decimeters cubed. So we know that 1 meter is 10 decimeters. So 1 meters cubed would be 10 decimeters by 10 decimeters by 10 decimeters, which would be 1000 decimeters cubed. So now 8 meters cubed, which is the volume of our room, is 8000 decimeters cubed in volume. So we know that 1 mole of gas, we've just said, at room temperature and pressure gives a volume of 24 decimeters cubed. So if we want to go from decimeters cubed to moles, we have to divide by 24. So that's the same thing we have to do over here. So with our volume of 8000 decimeters cubed, we need to do 8000 divided by 24. I can't do that. I'm not sure many people can do that. So let's just estimate again. So to make kind of the top and bottom number kind of divide simply, let's do, that's roughly 8000 over 25. Let's times the top and bottom by 4, so that would give us 100, which is nice and simple to divide by at the bottom. And then if we times the top by 4, that would give us 32,000. We can just cancel 2 zeros there, cancel 2 zeros there, which gives us 320. And what is this? This is moles of gas. So we've got 320 moles of gas in this room. So we're getting there, we're very close. This is the number of moles of gas in this room. We now want to work out the oxygen, so the moles of oxygen, and we know the oxygen is 21% of the atmosphere. Let's just make that 20%. So 20% is 1/5. So 320 moles, 1/5 of that would be 320 divided by 5, which is 6 into 2 there. So that would be 64 moles of oxygen in our room. So we're really, really close. Remember, looking back, we wanted to end up with the mass of oxygen in the room. And we all know the formula that is drilled into us in our GCSE chemistry, which is moles equals mass over mR. We want the mass, so let's kind of put the mass on the left side. So mass equals moles multiplied by mR. And we can just fill in the gap. So we know moles here is this, which is 64. Now the mR is important. So we know the atomic mass from our periodic table is 16. The atomic mass of oxygen is 16. But oxygen goes around in the atmosphere as a diatomic molecule as O2. So it'd be 16 times by 2, which is 32, which would be the molar mass of our oxygen. And that would be 64 times 32. Let's just estimate that as 60 times 30, which is 1,800 grams, which is 1.8 kilograms, which would be roughly the mass of oxygen in this room. And there we go. At that point, they didn't tell me if I was right, they didn't tell me if I was wrong with all of that estimation, but I don't think they were really interested in my final answer of 1.8 kilograms. I think they were just far more interested in how I worked under pressure, kind of my workflow behind each step of the process. Okay, so that's just a glimpse of one of the questions that got thrown to me at my Cambridge interview for medicine. I hope you found that useful. I think it comes down a lot to how you perform under pressure, using the knowledge you have from your GCSEs, the knowledge that you have from your A-levels, kind of making those connections, combining all that information to try find the next step along the process until you get to an eventual endpoint. So hopefully you found that fun, hopefully you found that kind of interesting. Let me know in the comments if you did, and let me know in the comments what other questions you might find useful, and I'll try my best to get the content out for you guys. So thanks for watching, guys, and I will see you in the next one.